BU Introductory EMME, question number 1, 2017. For each of the following propositions A and B, state if A is a necessary condition or a sufficient condition or both necessary and sufficient for B to be true. Okay, so let us look at the first statement. A, two numbers x and y are even. B, the sum of x and y is even. Now, obviously, if x and y are even numbers, x plus y will definitely be an even number. So, A is sufficient for B because A implies B. So, A is sufficient for B. Okay. Now, just look at B. The sum of x and y is even. Now, the sum of x and y can be even if both x and y are odd. Okay. So 3 plus 3 is equal to 6. So the statement A is not necessary for B to occur. So A is sufficient for B to happen. This is the only thing that can be guaranteed. A is not necessary for B to happen. Okay. Now, let us look at statement number 2. A is equal to minus 64 power 1 by 3. B is equal to x equals to minus 4. So now if A is equal to minus 64 power 1 by 3, if we solve it, it is going to be minus 4 power 3, 1 by 3. So that is equal to minus 4. So A definitely implies B. Okay. But even if A is equal to minus 16 by 4, we will get minus 4 as the answer. So A is sufficient over here. Again, A is sufficient for B to happen, but not necessary. Okay. Third, A, X, Y, and Z are three different points on a plane. B, X, Y, and Z are three different points on a circle. Now, if X, Y, and Z are three different points on a plane, then they can lie on the same line. Okay. So if these 3 points are on the same line, obviously they are not on the circle. Okay. We will be having a linear kind of a condition. So it is not necessary that when 3 different points are on a plane, they will definitely be on a circle. That's not necessary because on a circle, we will have a situation like this. Okay. So on a circle, these 3 points cannot be on a circle if they are on a line. So therefore, A is not sufficient for B. Now let us look at the other way around. If X, Y, and Z are three different points on a circle, now obviously a circle will definitely be on a plane. Okay. So then X, Y, and Z are three different points on a plane. So they have to be three different points on a plane. So in this case, A is not sufficient for B, but it is necessary. All right. Now, let us look at the fourth option. Now, what is A? Now, A says the second derivative of f at C is equal to 0. And B says x equals to C is a point of inflection. Now, if the second derivative is equal to 0, it is not necessary that x equals to C is a point of inflection. X equals to C is a point of inflection only when the second derivative changes sign from the left of C to the right of C. So it might happen that the second derivative is equal to 0 at C, but the second derivative is not changing signs on the sides of C, on the left and right side of C. So f double dash C equals to 0 is not a sufficient condition for x equals to C to be a point of inflection. So not sufficient. But if x equals to C is a point of inflection, it is necessary that the second derivative is equal to 0. So not sufficient, but necessary.